Okay. All right, everybody, welcome back to the channel. This video is essentially going to tie this whole thing together. Way back, you remember us doing some framing because essentially this garage slab sits over living space below. And so we had to frame a wood floor, put subfloor down, waterproof it so that we could put a slab, and it all had to be engineered because there will be two vehicles that can theoretically, depending on how messy the homeowners are, park in here every day. So let's get into it. Okay, since we're up here and it's finished, a couple of things that I just want to mention. This doesn't really have anything to do structurally, but it's more cosmetic. So there's two kinds of concrete. Concrete that is cracked, concrete that will crack. So the goal is for us is to control the cracking or tell the concrete, so to speak, where we want it to crack. So these tooled joints are called contraction joints. We put two in, essentially splitting the slab roughly into thirds. And the reason is we're gonna have vehicles that drive in and out. And because we have a wood floor, but then underneath this, we had bucked out the concrete. So the concrete here is about 10 inches thick, and here it's about 4 inches thick. So they had a joint tooled right here, which is the edge of the wood floor coming down to the concrete stem wall below. We're trying to force it to crack here. It's probably gonna crack there anyway, but let's just hide the cracks in the tooled joint. And then we also threw pieces of rebar across. Okay, one other thing that we did is to match the floor height of the main house. Because we're tapering from 6 inches to 4, obviously it would not be level across here, it would slope down. So you can see here with the level, basically they just feathered this section in so that we'd be able to wheel a wheelchair right in, or basically it's a zero entry. So you can see there, got the level. Let me go this way. And then same thing here. See how that just rocks and rolls. And they really did a nice job of feathering it where it's not that obvious. We're not worried about when two vehicles come in and it's been raining and the water comes off of those vehicles. We're not worried about puddles. We've done this before. In fact, one of my first jobs coming out after school was to hand nail all the joist hangers in this exact situation. 12 inch on center, that was not fun. It was raining that day and I got to stay dry, so that wasn't too bad. But anyway, the amount of water that comes off of a vehicle is pretty negligible.
No, but the difference is negligible.
It'll evaporate off. The concrete has a steel trowel finish, so the water's really not gonna go through the concrete. Even if it did, it's gotta go through 4 inches, 6 in the back, 4 in the front. And then of course we've waterproofed, so water is a non-issue. Here in the rainy Pacific Northwest, what we do sometimes is we just leave the garage door cracked like 4 inches, let it air out. So anyway, that is the finished slab. So the rest of this video, I'm gonna show you how we framed the floor system, explain a little bit about that, and then we'll show some B-roll of them placing the concrete and also the product that we used to waterproof. But it's vapor open, which means that moisture can still work its way through that material. And then go follow my brother at Pioneer Builders Inc. here on YouTube, Instagram. He's gonna explain in his build show videos a little bit more on the building science side. I'm just the structural guy. So anyway, go follow his account too. Seacrest out. What we've had to do to account for those lateral loads, here we don't have wind as a governing lateral load. It's seismic or earthquake. We're a high seismic design category D2, and so we have to think about if there was an earthquake, how would the structure need to be built in order to keep the occupants safe? It's not actually built in this area so that the structure would see no damage. It's about occupant safety. So let's turn it over to Tim, and he's going to talk about what the design was and the installation was in order to handle, again, our vertical loads as well as our lateral loads. I think we should start at the top just because it's easier. So right now we have Roseburg I-joists, 12 inches on center. They're attached to a rigid lam from Roseburg LVL. Now the original design called for I think it was like a 5.5 by 13.5 glue lam. But I asked if it could be redesigned with an LVL, hoping that we could get a smooth ceiling. Obviously, because it's 24 feet front to back, there was just no way that we're gonna have headroom, and I mean, the beam depth would be massive if we were to clear span without a column. So column right in the dead center. So all of that weight from the slab is carried by the joists, the joist hangers, the LVL, which has got a column on each end, and then a column in the middle. So the structural engineer analyzes all of those loads as they work their way down. Then underneath each of these we have point loads. I want to say, if I remember right, they were 30 inches by 30 inches by 12 inches deep, and then with a grid of steel. And that's to transfer those loads from above down into the soil. Same thing on the back, same thing on the front. Then obviously, because the joists are 12-inch on center, then our walls under them need to be 12-inch on center. And I did specifically ask the engineer, can we get away with 16 inches since we have double top plates? And he said no. And I mean, it was a very terse response. No, leave it as is. And it was like, okay. So I trust him. So joist 12-inch on center, studs 12-inch on center. Then the footing actually supports that wall as well. So the footing is like an upside down T. This part kicks in far enough that then that wall frames up to support the floor. The floor is not actually supported by the outside foundation walls. It's actually supported by that footing down and in. Same thing on the back here. Again, I think we probably could have got away with maybe a little bit bigger spacing. 16 inches on center, and then it's a shear wall, so it's got 7/16 OSB behind it. The wall up above in the back of the garage, same thing. So that's our shear wall going up. Same thing on this wall, that's our shear wall going up. So it's sheeted up above there as well. And then of course everything's bolted to the concrete, to the big footings with all the extra steel. There's a lot of concrete in this job and a whole lot of rebar. I think that covers the structural. Let's go back in time. So you saw the house as it is now, concrete's placed in the garage, etc. Let's go all the way back and show you the bones, so to speak. We're looking at the foundation on the day that we started pouring concrete for those foundation walls. You can see though all the interior strip footings, all of those have rebar, and that is what is going to support the loads from above, all the way down to the soil. Now specifically, you notice right there, almost dead center toward the bottom, we have a blue bucket. That's on that expanded footing. That supported one column for that LVL that you just saw. Then you see that big footing. It might have been 36 by 36 now that I'm thinking about it, 12 inches deep with rebar going each direction. So all of that is going to support the system up above, including the slab and vehicle loads. And now we're going to cover up all of that work. So the majority of the slab has foam insulation under it, but we left that out, and you can kind of see they poured that first, and now they're pouring the slab over the top. We left all of that cut out because the foam is not rated to carry those gravity loads that we talked about. There's no way to see now without the drone that we had all of those point loads and footing. A minute ago I mentioned that there's a lot of concrete in these foundations. Between the two basement slabs here that were poured that day, if I recall, I think it was 70 or 75 yards total. I can't remember what the footings and walls were. I think the walls were 36, something like that. And I can't remember footings. Let's just say there's well over 100 yards of concrete in each of these two jobs. So a lot of concrete, but we need to restrain the earth up above and carry all those gravity loads down below. And then of course that basement slab is part of our floor. And speaking of framing, now we're going to fast forward again into winter time. On the right hand side, you can see that we have 3 different wall heights. The very far right, 2 foot on center, the top of that wall is matching the top of the joists. The back wall of the garage, that's the one with the doorway and the header, that's framed 11 7/8 down because that's the height of our floor joists. So that would match the back walls. And those walls on the left. Notice how the floor system was designed to sit on interior walls and essentially flush out with the top of the mud sill. That just lowers the number of steps coming into the house. Now, where Noah's at, we have to frame that wall 6 inches lower than the standard wall because we want that whole floor system in the garage to be 6 inches lower. That way we can taper the concrete from 6 to 4 inches in the front. So here's a little bit better look at that. That's the LVL going in. That's the 5 1/4 by 11 7/8 rigid lam. Notice how it's sitting on a 2x6 wall that is then sandwiched with 1 inch of foam. So that wall will get insulated, and then we have a thermal break. Additionally, you notice that the concrete right where I'm at, that's all been bucked out. So we poured that, I think, 7 inches lower, just to give us a little bit of room. And you can see the verts, the rebar, that will have to get cut off. So essentially, the concrete then is going to be roughly 10 inches thick right at the opening, but then when it transitions to the wood floor, well, that's why in the opening portion of this video, we had them do a tooled joint right there. And here we can see the actual floor being framed. These are 11 7/8 Roseburg I-joists. They fit into the Simpson Strong Tie hangers. So all of these calculations are done. What will each joist support? What does the beam support? We cut that in half. Then is the column strong enough? How big of a footing do we need? There on the left, you can see that buck out again. And now here's the difference in floor elevations between the main floor, or really the house, and the garage. 6 inches. Again, just looking at it from this perspective, it kind of just looks like a sunken living room in some of those old floor plans. You notice too, at the garage opening, we just left the Advantech long because it made it easy to go in and out, and it also protected us from that rebar. And so we just cut that off even with the back of the stem walls when we went to waterproof that assembly for the slab. So here's the perspective of actually rolling the joists. And so let's just run through this again. In the foreground, you can see that we framed our wall, our exterior 2x6 wall at 24 inches on center. There's no reason to go any tighter. It's a short pony wall, right? So let's save the material, let's increase the thermal efficiency of the wall. And at the same time, let's go ahead and frame it to the top of the joist layout itself. So then we don't have to install a rim, a nice strong connection. Now where Kyle and I are rolling joists, those are those standard height walls. And so he's standing on the wall that is a standard height, but the wall to his right, you can see, is 6 inches lower. I think we've belabored that point enough, but this just shows that there's quite a number of things to think about, none of which are overly difficult. They just take planning, right? Hey, we're in construction, this is what we do. Again, you can see on the right-hand side, our interior walls are framed 11 7/8 lower than the mud sill height. And again, that's just so that the floor sheathing can just go right over the top of that, and it saves a couple of steps into the house. And you can see that in the distance. Notice how the top of the floor system, it's flush with the far pony wall, and it's also flush with the top of that mud sill. Now, all Kyle and I did in the previous video is we just set out the joists. The next day, everything is scattered. That's when we're going to start actually nailing them in place, and that's what you can see me doing. This gives you a little bit better look too about how, where I'm at on the planks, you can see then that the pony wall by my coffee, you can see that that's 11 7/8 tall. And then if you look over where the radio is at on the right, you can see that interior wall that lands on a slab, that underneath that slab is supported by the footing. We had widened the footing. That's what the engineer had us do on that section. Clear as mud. Again, just nothing crazy about it. It's just, you just take everything in a sequence. And what this allows then is most of the time, we wouldn't have access to all of that space underneath the garage. Well, now we got lots of space. And we were speculating, Kyle and me, if this was our house, you know, that slab would be a pretty good sound deadener. With some sound deadening insulation, boy, you'd have a great music room for the kids. You know, nobody needs a man cave. We just need a place for our drums and guitar, right? Or I suppose it could be your man cave. See, even cleaning the grooves on the Advantech. By the way, this is after the whole winter. You can see all those grooves, they didn't tighten up. Anyway, so that's why I had to use my chisel to clean them out. Now we were ready to waterproof the surface there in order for concrete to be placed. In the back behind Brian, you notice that we've sheathed that wall. That's a shear wall. The engineer called that out. That's stacked over the one that you saw in the crawl space. Also, the one behind the camera is fully sheathed as well. So in a sense, it encloses this area. Made it easy for us to put down this membrane. So this is the Slope Shield Plus self-adhered. And now what makes this different than just normal ice and water shield is that it's vapor open. So this is not a perfect analogy, but just think of it, the purpose of it is similar to like Gore-Tex or other fabrics like that. And basically what that means is we're trying to let water vapor out, but then prevent bulk water from getting through. So like your hiking jacket. We want to stay dry if we're hiking in the rain, but we also want it to vent the water vapor that comes from sweating, right? As far as working with the product, it's easy. It's just a sheet grid. You noticed how I was pulling the release paper and the roll just came with it and it stayed nice and straight. You notice how we've just followed the line on the Advantech panel? You want to roll this stuff though with a heavy roller. And so we borrowed our carpet guy is a friend of ours. He has a 100-pound roller that he uses for vinyl flooring. And so we found that if we went like side to side and then front to back, then we got pretty much all the bubbles out of it. So this is where Brian's at. And what that does is we're just getting the adhesive to just roll right into the Advantech panel. Before we roll it, it's really easy to reposition it. But then once you roll it, that's not so easy. And now it is time to place the concrete. You notice that we did not put a grid of steel in there. Like we mentioned at the beginning of the video, there's going to be contraction joints. We don't need the steel here to reinforce the concrete for those vehicles. The PSI is plenty high enough with this thickness of concrete, as well as a nice smooth base underneath it, right? It's nice and smooth. And so we just elected, let's just save the time and labor. The rebar is not going to help. Now, how do we know that? Because at length we reviewed this with our structural engineer. So don't take my word for it. Take your engineer's word for it. Now, your engineer might say something different. And that, quite frankly, is the nature of construction. Incidentally, I think we mentioned this earlier, but we have been doing a detail like this for years. Like the early 90s, we had 2 house plans in a development that we built out up in Countryside. That was the name of the development. 2 of them had this basically the same detail, the only difference being instead of I-joist, it was sawn lumber, 2x12, 12 inches on center. Okay? So again, it's just one of those things that, yes, you get the structural engineer's analysis, you review all of it, you make sure that you follow all of the steps, and then your area might have a little different requirements. Now, here's those joints being tooled. Sebastian just does such a good job at this, by the way. Incidentally, here's one piece of advice. Unless you have as much experience as the subcontractor that's doing the work, listen to them. So Sebastian has been doing concrete for a long time on a variety of residential and commercial job sites. And he just makes it look easy, right? So we asked him, we're going to have 2 vehicles come through this. Here's the wood floor. Here's the assembly. What do you recommend? And he instantly was like, let's do 2 control joints. So he measures the opening, 16'3", and mentally he goes, okay, so we'll have joints at about 5'5" inches. And I was like, let me get my calculator out. He was dead on the money without using a calculator. Anyway, the bottom line is, or my point is yes, you might know more in certain respects about the materials and other things, but never feel like you know it all. And of course, it's nice if the subs too, even if they're specialized and have a lot of experience, it's nice when they listen as well. So Sebastian recommended 2 control joints, 1 down the middle going east-west, and then he wanted to match the back side of the framing on that wall where the wood floor changed to that stem wall, and we talked about that earlier. And so he put another joint there. And the joints are right on the money. Anyway, incidentally too, I just let the time lapse run. He spent the afternoon training his son, so you know, it's a beautiful thing. We need people in the trades, and we need to do a better job teaching, which is kind of the whole point of this channel. So if you have any questions, please ask them below. What I'm going to do is link, it might be that the videos come out for the build show in the future. I will try to remember to come back here and link to them. Otherwise, if you just go to Brian's channels, which are linked below, then you can see the build show stuff there too, or just go to the Build Show Network and subscribe. It's free. And you can see the follow-up. Brian gets a little more technical on some of this. Anyway, I think that is enough for this video. Now you can see how we started all the way from excavation. You know, the big thing here, right, is if you imagine there's 2 vehicles, well, how does that weight all get transferred down? And you can see it's through the floor joist, the hangers, the beam, the columns plural, the concrete pier pads down below, ultimately down to the earth. And along the way, we need to plan for allowing vapor to get out and waterproof this thing, right? So, hey, thank you very much for following along. Hope you enjoyed it. If you have any questions, ask them down in the comments below. And don't forget to hit that like and subscribe button.